Hello everyone, I'm Meng from Hebei University of Technology. In the following, I would like to share with you the work of our research group, Multimodality Invariant Learning for Multimedia-Based New Item Recommendation. Here is the outline. With the development of the internet, individuals are exposed to abundant multimedia content, such as short video sharing, applications such as TikTok, Bilibili, and the e-commerce platforms such as Amazon. Multimedia-based recommender systems have become indispensable components of these online services, aiming at learning user preferences from multimedia content. However, in real-world scenarios, multimedia-based recommender systems has distinctive characteristics. First, a huge number of new items emerge rapidly over time, particularly on the news and the short video sharing platforms. For example, about 500 hours of video are uploaded to YouTube every minute. In multimedia-based recommendation, I think it is important to make the new item to be quickly recommended to keep freshness. Second, real-world items exhibit varying degrees of modality missingness. For example, in Twitter, some tweets have all the text, audio, and image modality, while some others only have text, and the others may only have text and image. Nearly all previous works relied on modality completeness for recommendation, or simply tracked these issues with pre-processing technologies to impute missing modalities. Therefore, the recommendation performance is harmed by the inferior pre-processing quality. In summary, we argue that how to track the new item and the modality missing issues in multimedia recommendation is important and has not been well studied before. We provide an interactive experiment to demonstrate the challenges of the problem. As shown in the figure, we assess the performance of a classical multimedia-based recommendation model under different settings in the Amazon Baby dataset. All samples in the original dataset have two modalities. We set three settings. In the setting 1, we use the original dataset with no modality missing. In the setting 2, for the training and the test sets, samples are randomly lose one modalities. And in the setting 3, only samples in the testing set randomly abandon lose one modality. Features for missing modalities are filled with the mean value. We can clearly observe a decline in model performance in the setting 2 and the setting 3, indicating that the modality missing has a substantial harmful effect on the new item recommendation. And it should be noted that the performance in the setting 3 is much worse than setting 2, showing that when there is a discrepancy in modality missingness between the training and the test set, the model's performance experience a more significant decline. It also demonstrates that simple data preprocessing and moving the training samples with modality missing are ineffective, and may even worsen the situation because it may larger than distribution gap between the training and the test set. To overcome these challenges, we think that users' inherent content performance is stable and better kept invariant with arbitrary modality missing. Therefore, an ideal recommendation model is encouraged to predict each user's performance as invariant as possible. To achieve this goal, we draw inspiration from the invariant learning, which can achieve guaranteed performance under distribution shift and received great attention in recent years. Invariant learning models correlations invariant across different training environments, where the environments are variable that should not affect the prediction. Analogously, we want to learn the user's inherent content performance that is invariant to any modality missing. However, implementing this acknowledge is challenging, as users' interaction records are limited, and how to construct environments to generalize any modality missing is a challenge. In this work, we propose a novel Milk framework for this challenge task. The Milk consists of two modules: the cross-modality alignment module for better item representation learning, and the cross-environment invariance module for user invariant performance prediction. Specifically, in the cross-modality alignment module, we devise alignment functions that allows one modality to capture content signals from the other modalities. This module ensures that the absence of a specific modality does not hinder the extraction of features from the other modalities. We use alignment across modalities to guarantee the semantic consistency between representations of different modalities. This module makes the information between the modalities be transferred to each other. When a certain modality is unavailable, other modalities can provide us supplement. We achieve this goal by optimizing the following distance-based alignment objective. After the multimodal representation alignment, we execute the following module as follows. The heterogeneous environment construction and the invariant user performance learning in various environments. For the heterogeneous invariant construction part, we propose a flexible and unique environment construction method called the circle mix-up, enabling simulates the different modality missing situations. We assume the existence of multiple heterogeneous environments, and each with multimedia features drawn down from a different distribution, and we build multiple environments by adjusting the proportion theta m of each modality m, and the zj is the item j's representation. Specifically, in the case of the three models, we first sample three values from the Dirichlet distribution as width for the first environment. Then, through the two circle displacements, we construct two new widths. That is, we simulate two new environments. Additionally, since the test state model density and mass are unknown, we can only use the strategy with equal widths for processing. We also expose these strategies to the model as an environment during training. With the circle mix-up, we ensure that each environment is dominated by a different modality, and each modality will play a major role in a certain environment. This ensures that there are some models in the simulated environments with observed insufficiently information, and at the same time, no arbitrary models are ignored. Given the construct environments, we conduct stable user performance learning based invariant risk minimization principle. We argue that users' inherent content performance is stable and better kept invariant to arbitrary modality information distribution. Hence, we encourage the model to maintain performance in heterogeneous environments. To do this, we train the model using the invariant learning paradigm to learn an invariant preference prediction machine. We use the optimization objects as the formulation, where the first term is the task-dependent loss used to guarantee the recommendation performance, and the second term is the constraint over the loss variance across environments, which encourage the model to be stable across different environments. Our experiments were conducted in the co-star scenarios with missing modalities. We have two settings. Under the first experimental setup, we guarantee that the training set is modality complete. And in the test phase, we randomly pick 50% of the item and randomly remove one of their models. We selected 3 real-world datasets with multimodal features for our experiments. Among them, the baby and the clothing are from Amazon's dataset and have 2 models of item pictures and text descriptions. And the TikTok is characterized by 3 models, text, video, and audio. We compare with baseline methods and show the consistent superiority. In addition, we consider more realistic and also more difficult scenarios. In the second experiment setup, we pick 30% of the items in the training set, so that they are missing a random model, and we randomly pick 50% of the items in the test set, so that they are missing a random model. And the experiment shows that our model also exhibits the superiority in the more difficult scenarios. In addition, we also conduct the evaluation experiments to verify the effectiveness of each module. And the experiment shows that our strategy of constructing the environments induces the heterogeneous environment with some favorable properties and improve the performance of the model. Our contribution are summarized as below. We emphasize the significance of addressing the modality missing issue in multimedia-based new item recommendation. We argue that users' underlying preference is invariant to arbitrary modality missing environments, and treating this problem from an invariant learning perspective. And we propose a new framework for the challenge problem. We design a novel circle mix-up method which constructs heterogeneous environments with different modality information portions, thereby adapting invariant learning with continuous values and augmenting limited training data for invariant user preference modeling. And here is our paper and the code. And if you have any questions, please feel free to contact us.